Hey, what's going on? Today we're going to be doing the seventh example from the energy unit, and let's get going. So we have reading the problem, so I'm starting right here. We have a super ball that is dropped from some height, and when it bounces, it only makes it back to half its original height. So I'm already thinking there's some type of gravitational potential energy play here because we're talking about things falling and changing their heights. So construct an energy bar graph of the situation with only the ball and the earth in the system. So that's important how we set up our bar graph. So I'm just going to sketch out a bar graph real quick. And then we have our flow and then our final bar graph. And like it says, only the ball and the earth are in our system. So we write them right there in our little flow diagram. And I know it starts at some height, so I'm just going to give it some arbitrary number of boxes. So let's give it 4 boxes of energy right here. Then I'm going to label that gravitational potential energy. So that's what it starts with. It's not moving. It's not anything. We're just holding it at some height. And then we drop it, and it only makes it back to half its original height. So that means it only has half the gravitational potential energy. So if it started with 4 blocks, I know it's going to finish with 2 blocks. So remember, law of conservation of energy states that, we can't just lose energy. We have to keep track of it somewhere. So no matter what, we need to end up with 4 blocks of energy at the end. So if we're just missing 2 blocks of energy, that had to go to some other type of energy account. And so if we know we lost it somewhere, generally that's going to go to the thermal account. Something happened when it bounced. The object changed its shape, which raises the internal temperature a little bit, which we can call thermal energy. Okay, so that's what our bar chart looks like. Now, if we go to the second part, we have if the super ball is 1 kilogram, so that's giving me mass, and it's originally dropped from 2 meters, that's giving me an initial height right there. How much energy is lost from the bounce? So that's basically asking how much energy is actually in this thermal energy account at the very end. Okay, so we have law of conservation of energy. Remember, we used this bar chart to set up our energy equation. So law of conservation of energy right here states that the sum of all of the energies on the left side of that diagram, all the initial energies, needs to equal the sum of all the final energies. So we always start with that beginning step with an energy problem. And from looking at our bar chart, we know all the initial gravitational energies have to equal all the final gravitational energies plus that thermal energy that built up. And so once we have that just kind of qualitative energy equation set up, now we can start substituting in the formulas for each one. So I solved for the thermal energy account right there. And then we can substitute each of our equations for gravitational potential energy. Right? And then we're just going to simplify it one last little step. If you look right there, both of these terms have an mg. Right, so we can factor that mg out and make it a little prettier, where we have mg times the quantity of initial height minus final height. And so we'll continue this on up here. All right, now I just plug in my values. So I know that the thermal energy is going to equal the mass, which is 1 kilogram, times g, the gravitational field strength. And on Earth, that's 10 newtons for every kilogram of mass. And then we have our change in heights. So the original height was 2 meters. And it only made it up to half the original height. So the final height was 1 meter. Okay, and then to find how much energy is in that account, all we do is multiply all that stuff together, which gives us a final thermal energy of 10 joules. Okay, so it started with 20 joules of energy. It lost half of it. So in that thermal energy account, we have 10 joules of energy. Okay. The second part, it says, what are some factors that could cause this energy loss? So when balls bounce, right? Anytime something bounces, there's a little bit of change of shape, right? So the change of shape could be a factor when things shape changes. A little bit of the internal temperature raises up, which causes thermal energy, right? Change of shape, that could be a thing. Some energy has to go into making the sound, right? When you hear a ball or hear anything bounce off the ground, some of that energy from the bounce gets transferred into the air, and that's what goes through the air that ends up tickling your little ear hairs, and you hear it, right? So the sound took some energy. I mean, gosh, the ground could take some energy out of it, right? The bounce definitely affects the ground, so the ground could take some energy out of it. But all of these things, right, it all kind of would add up to that 10 joules of energy loss. So, yeah, it's not just thermal energy. That's just the storage account that we made to keep track of how much energy was being lost. Okay? So if you have any questions on this or anything, leave a comment or talk to me in class, and I will see you guys later.